Okay, the next section is 4 or 5. We're going to talk about graphs, tangents, cotangents, secant, and cosecant. These are the remaining ones we have left because we've done sine and cosine. So first is tangent. Here's the tangent function graphed in blue right here. I've got some information on the formula sheet for you. So our standard form is going to be f of x equals a tangent of bx plus c plus d again, where we can change the period, we can shift left or right, and we can move it up or down, and also stretch it vertically. Most of the time we won't deal with vertical stretch. It's a little hard to see anyway because it'll look the same, but it'll just be a little narrower. But some things that you should know are like things like asymptotes. The tangent function really is sine over cosine. And so it's not hard to see that the asymptotes are where cosine is 0. So cosine is 0 on the unit circle when you're at pi over 2, and then any additional pi from that point. So basically I'd write pi over 2 plus any increment of pi. Those are where all the zeros of the cosine are, therefore those are all the places where the tangent's undefined. So the first one's at pi over 2 right here, and the next one then is at 3 pi over 2 right there, and so on. Okay, the same thing, you could do the same thing for the zeros of the tangent function. The zeros of the tangent function, once again, tangent is sine over cosine. So the tangent is going to be 0 where the sine is 0. So the sine is 0 at 0, then at pi, and any increment thereof. So it would just be any increment of pi, so n times pi. And you can see that that's where the tangent has a 0, where the sine function is 0. So the cotangent function would be just the opposite because cotangent is the reciprocal, so it would be cosine over sine. So now the asymptotes, if you graph sine, are going to be where sine is 0, as you can see. And the zeros then are going to be where the cosine is 0, as you can see. All right, next is the secant function. Secant's really 1 over cosine. So you can see that this thing's going to be undefined wherever cosine is 0. So you can see the cosine's graphed, and wherever it's 0, we have it undefined, as you'd expect. It's got kind of a weird parabola shape on each branch then. The cosecant function here is 1 over sine. So you can see I've got sine graphed, and whenever this is 0, it's going to be undefined. So here's a summary of all of the information then that we've covered for all of our 6 trig functions. So you're going to want to look over this, be familiar with it. I am going to ask you questions about whether a function is even or odd. And keep in mind that if it's even, this is on the formula sheet, f of negative x equals f of x. And if it's odd, when you plug in negative x, you get opposite the function back, opposite the y value. So those are our even and odd tests that are on the formula sheet. And just be familiar with where the zeros are at, and be familiar with this kind of thing where the cosine is 0 at 90 degrees, but also, every time you go around the circle, it's 0 again down here. And then if you keep going around, it's 0 again up there, and so on. So that's why we do this any multiple of pi after 90 degrees. And that should be about it. Let's do one example though. Here's an example solving a trig equation, but this is from a graph. So just graph the left and graph the right and find the intersection point. Now I'd probably tell you to find the solution in an interval. So let's say like negative 2 pi to 2 pi. Let's say the smallest possible number x in this interval here. Because if you look at the graph of this, you can see one of them is a parabola, and then we know the secant looks like this. Obviously this parabola keeps going down and to the left as well, so it's going to be negative infinity then for the lowest possible x value, because there's going to keep being solutions to this. There's an infinite number of solutions between the intersection points for these two. So if we want to find the smallest one in an interval, that's more realistic. In fact, it's probably more realistic to do negative pi to pi even, so you don't have to look so far. Negative pi to pi, we can look at this one. That one's definitely within the region because pi is negative 3.14, or negative pi is negative 3.14. So that one would work. Let's take a look at the next one, which is right here. That's outside of pi. So I would have to say my answer for the interval from negative pi to pi would be negative 2.046. So x is equal to negative 2.046. And if I was looking for a solution, you know, the smallest possible x between negative 2 pi and pi, then I could go back further. Obviously this one would work. Let me check the next one. Next one's down here. That's outside of 2 pi because 2 pi is negative, or negative 2 pi would be negative 6.28. So I'd have to use this x value right here is my smallest one, negative 4.662. All right, so we'll do a lot more with solving trig equations coming up, but for now, let's try the homework problems and hopefully that'll help.